Okay, that's the instant of truth. We're gonna turn it on. Hopefully it doesn't blow up. Alright, I have a dead screen. That's not good. Oh, alright, it's time to troubleshoot.
Okay, so at this point, obviously all the wires were correctly inserted in their sockets, but I could not see the ones coming from the PSU because they were hidden by this black plate. So I had to remove the black plate, but I was hesitating because it's a pain in the butt to put back.
Yes, great. Alright, it's working. Self-test will now begin to check for potential assembly-related issues. Fan test.
Pass, pass, pass. Tap the nozzle and beep. Okay, retry.
Checking axis. X-axis, Y-axis, Z-axis. X-axis passes. Y-axis. Y-axis passes. Z-axis. Nozzle heater check. Preparing. Preparing. Done. Heat break status. Done. Heat bed heater check. Preparing. Done. 156, 7, 8, 170, 175, going all the way to 290 degrees. The gearbox calibration is only necessary for user-assembled or serviced gearboxes. In all other cases, you can skip this step. Okay, continue. Before you proceed, make sure filament is unloaded from the extruder. Rotate each screw counterclockwise by 1.5 turns. Gearbox alignment in progress. Please wait approximately 20 seconds. Tighten the M3 screws firmly in the correct order. They should be slightly below the surface. Do not over tighten. And 3. Continue. Close the idler door and secure it with the swivel. The calibration is done. Filament sensor calibration. We need to start without the filament in the extruder. Please make sure there is no filament in the filament sensor. Is filament in the filament sensor? No. Insert the filament into the extruder until the sensor detects the filament. Alright. Filament inserted. Press continue. Remove filament to finish. Filament sensor calibrated. Self-test OK. Alright. Ethernet connection. Ethernet cable not plugged in. Wi-Fi connection inactive. Okay? It's correct. Happy printing. Use the online guide to set up your Wi-Fi. Not now. Alright. Let's load some filament. Alright, this is PLA. Waiting for temperature. (150 degrees). 160, 170, 180, 190, 200, 1. Is the color correct? Purge more. There we go. It's coming out. Wonderful. Perfect. Is the color correct? Yes. Alright, no USB. Alright, so let's fix that. Okay. USB key. Alright. Spatula. No, I don't want that. Print. Keychain. All right, keychain. Print.
While we are doing our first print, I probably need to say a few things. The first one is Prusa was actually Prusa Research, the company that makes Prusa printers, was started by Joseph Prusa. He's a Czech Republic citizen. He lives in Prague. That's where Prusa has their factory. Joseph Prusa dropped out of college in order to start Prusa Research. And what motivated him was he tried to build an open source printer. Back then there was a project called RepRap that was building 3D printers out of commonly available parts. And he took this and he actually created the MK1 and then MK2, MK2.5, and every time he is doing a new version, he's basically doing iteration on that open source project. So RepRap became actually the main branch of RepRap, probably the most common printer, became Prusa Research. Can you build a Prusa out of parts? The answer is yes. You could go on AliExpress and Amazon and buy all the parts of a 3D of a Prusa 3D printer. And because the software is open source, you could actually get yourself a Prusa printer for actually a fraction of the price. Not very many people do that because of course you don't have the warranty, you're losing the Prusa support and so on. Now, should I have bought a MK4? That's a tough question. So I need to say a word. I had experience with Creality printers. A couple of acquaintances actually bought those because they are $200 and some dollars, and they're much cheaper. You could get probably 4 Creality printers for the price of one Prusa. In my experience, especially for a beginner, they don't work. A Creality printer at this price, their entry models are underperforming, and it takes some expertise to actually set them up. So should you buy a Creality? Yes, if you have a lot of experience. If you're buying a Creality for your kids for Christmas, this is a terrible idea. I had this young kid, his mom bought a Creality not knowing exactly what to buy, and we spent a couple of days to actually fix all the tiny problems. The tuning is actually difficult. Prusa is self-tuning. The Prusa printer head is going to, on the MK3, is going to use the magnet sensors to figure out how far it is from the print bed. It's not perfect, but it was kind of working pretty well. On the MK4, it actually probes the printhead probes the surface of the print bed and figures out where the print bed is relative to the printhead. So in fact, you get the first print, the first layer, the printing of the first layer is always good. It's a good layer out of the box. There are other brands that you could consider if you are looking for competitors to Prusa in the same price range. Two of them come to mind. The first one is Anycubic. I own one Anycubic printer. It is a really good brand. And the other one is Bamboo Lab. Actually, the MK4 is actually an answer to Bamboo Lab because Bamboo Lab was actually stealing a lot of market share from Prusa. The Bamboo Lab X1C is actually about the same speed, about the same print volume as the MK4. It's substantially more expensive, however it comes with its enclosure. What I like in the MK4 though is that you have upgradability. My experience with the Chinese printers, Creality, Anycubic, Bamboo, is that the parts are hard to get. The new firmware doesn't come very often, and the Chinese brands have a tendency of actually making the new model and forgetting about the old ones, not upgrading the old ones. Joseph Prusa, because he's worked open source since the beginning and because he was actually tinkering at the beginning, as a path to upgradability. I chose not to upgrade my MK3 printer, but if I had wanted to, I could have spent $579, I believe, US dollars, and I would have gotten all the parts in order to upgrade my MK3 to MK4. Because I have two MK3s, it would have put me back $1,200. I'm better off buying a MK4 since my two MK3s are working really, really well. But you get a path to upgradability. People who had MK2 printers were able to upgrade them to MK2.5 and then to MK3 and MK3S and MK3S Plus. It's going to be the same thing with the MK4. When new models or new versions of the MK4 come out, we're gonna be able to take them and upgrade them. And a good example is the firmware. So this week, as I'm actually editing this video, the new 5.00 firmware came out for the MK4, and it implemented input shaping for the MK4, and that doubles the speed of the MK4. So that makes the MK4 twice as fast as the MK3, and you get that for free. I mean, you bought if somebody would have bought an MK4 three months ago, would have gotten that, and they would have a new MK4 today with twice the speed of the original MK4. We're gonna be able to get new parts, and in a few weeks we're gonna be able to get what's called the MMU3, which is the multi-material unit version 3. I own a MMU2S, the second edition of the MMU2, and that allows you to actually print multicolor objects. It's very cool, and it's a great upgradability. The other thing you can do is you can actually build an enclosure. You could build an enclosure by yourself, and it's gonna cost you about $100, and you actually can use your 3D printer in order to build the enclosure, and that's gonna be my next video. In my next video, I think it's important, I'm going to explain how to build an enclosure for the MK4 on a budget. So without spending the $340 that Prusa charges for their enclosure. Do you need an enclosure? So that's an important question. If you're printing PLA, the answer is no. I've printed for about 2 years without an enclosure at the beginning, and it was printing great. If you print PETG, the temperatures are slightly higher. So actually I should say PLA is polylactic acid. This is the most common filament. The next most common is probably PETG. PETG is a bit more elastic. It's actually more resistant because it's a bit more elastic. It's harder to break. And PETG is the polyethylene terephthalate glycol, I believe. And that's PET is what water bottles are made of. The next, and it prints at higher temperature. So as soon as you get higher, as soon as you print with higher temperatures, you're better off having an enclosure because it keeps the heat inside of the volume of the printer, and you do not have dissipation of energy, and you don't have air current that prematurely cool off your parts and make them breakable or make them fragile. So you're much better off having an enclosure. And then if you print ABS, which is the next step up, which is the acrylonitrile butadiene styrene, you almost need an enclosure for two reasons. Contrary to PLA and PETG, ABS is a bit toxic. It releases toxic fumes. You're better off keeping them in the enclosure. And it prints at 250 degrees, 260 degrees at least. And the next step up is ASA, even hotter, and it's called acrylic styrene acrylonitrile. So it's an acrylonitrile as well, it's like ABS. So the first A in ABS and the second A in ASA are the same thing, acrylonitrile. ABS and ASA almost require an enclosure for those two reasons, temperature and toxicity. If you're printing and you're actually giving a 3D printer to a kid, it's a really good idea to actually stay with PLA and PETG at the beginning. Kids do crazy stuff and there's no need to give them filament that's potentially toxic. And that brings me to another point. During the first two videos I talked about SLA versus FDM. FDM is deposition layers, deposition manufacturing. We are adding layers upon layers upon layers and they come from that filament. SLA is stereolithography, and the way it works is actually exactly like your fillings at the dentist. You're actually taking a resin, liquid resin in a vat, and you're actually on the print bed, you're actually shining UV light laser, and that very quickly, few milliseconds, and UV light laser is actually polymerizing the resin. And as you're actually raising the print bed, you're actually printing newer and newer layers with SLA. SLA resins are generally toxic, or they all emit fumes, and some of those fumes are toxic, and that's another bad idea for kids. So if you're at the crossroad and you're thinking, should I buy FDM or should I buy SLA? I love my SLA, don't get me wrong. I have the newer Anycubic Photon M3 Premium, and that's really a premium printer as its name indicates. It's 8,000. It's 8K, 8 million pixels on the print bed. It prints absolutely gorgeous parts. It's very, very good for figurines. It's very good for small statues. It's excellent print. For anything artistic, SLA beats FDM any day. However, it's really something for adults. So I would stick. A lot of people are actually buying 3D printers exactly like people were buying Commodore 64 and Apple II in the 1980s. FDM printing, 3D printing, SLA printing are the thing of tomorrow. Everybody is going to have a 3D printer at home at some point, I believe, and I think it's very much like the computers, the personal computers in the 1980s. It's still imperfect. When you buy a 3D printer, you're actually buying a Ford T. You're supposed to be able to tune the carburetor. You're supposed to be able to do a lot of maintenance by yourself. However, you're starting to learn something new and something that's going to be very, very important, which is manufacturing in the 21st century. Manufacturing in the 21st century is going to be much more akin to agile programming. So we won't have waterfall models for developing parts. We're actually going to go in the CAD software, do a part, and quickly print it and iterate on that first print and iterate on that first print. And we need to have a 3D printer on our desks to do that. In my case, they're in the basement, but you get the point. The next important point that I need to talk about is the firmware. I just brushed about it. The firmware 5.0 came out. And I just did some tests and I created two parts. I printed two parts. I printed the one that comes on the printer. And as you can see, they're beautiful parts, really nicely done on the part of Prusa. But I also wanted to make sure that it's not a fluke, that it's not the slicing, that they didn't tune it to the point where the only thing you can get right is something they give you. So I went on Fusion 360, I created a few parts, and in particular I created a part that has two cylinders out of a rectangle with a hole in the middle. So I'm creating challenges for the printer, and one of those challenges is stringing, and I wanted to know what it's doing. The printer came out and then printed the part really well, actually better than on my MK3. The quality is perfect. I used, since I had the new firmware 5.0, I used the new option called input shaping, and I'm not gonna go into what input shaping is, but be aware that input shaping is there now on the MK4 since September 18th, 2023. It speeds up the printing by a factor 2 on my part. So my part on the MK3 came out in 12 minutes, on the MK4 it came out in 11 minutes, and on the MK4 with input shaping it came out in 6 minutes. So in fact you go from 12 minutes to 6 minutes, you're doubling the print speed. So it's great. And the quality, I could not, you can look at that picture that I've inserted in this video. I have no idea which one was printed with input shaping, which one was not. I had a tiny bit more stringing, maybe epsilon-esquely worse on the input shaping for the stringing, but the final part, because I removed the tiny strings, the final parts were absolutely identical. I can no longer tell which one came out of the input shaping slicer. Now, do we have downsides? Yes. The first one is that the website that controls the printer, so you get a website that you can access your printer from everywhere if you want to, if you know how to configure your firewall. That's outside of the scope of this video. But that website is poor. I had better results with Octoprint. At least for now, I'm going to stick with Octoprint. Is it a downside? No, because Octoprint is still there and it's really good. So I'm not going to suffer much from that. There's no touchscreen. So the LCD is touchscreen capable, but the firmware does not implement touchscreen yet. So I was kind of surprised. I was at the beginning of this video, I was clicking on the touchscreen and I couldn't get anything out of it. The wireless setup is poor as well. So the only thing you can enter for the wireless is the name of your wireless network and the password. The wireless network has to be 2.4 gigahertz. You cannot be on a 5 gigahertz network. So if you want to, if you're set up with a 5 gigahertz network, you're gonna have to go find a new router or something like that. Should it be like this? Probably not. And the fact that you're only entering the SSID and the password means that the printer is actually using a DHCP to get an address. So if you want to do an IP address assignment, like I do, I have maybe 100 IP addresses at home, because I have Raspberry Pis everywhere, I have cameras everywhere, I have modern houses. All the switches and everything is controlled by IP and by websites in my house. I use WLAN a bit everywhere. I mean, so I have over 100 different IP addresses on my networks, and I said networks with an S at the end. And if you want to assign an IP address, your only option is DHCP. So you're going to have to go to your DHCP and you're going to have to assign an IP address using the MAC address of the printer. By the way, the MAC address that appears on the test results, on the proof that they do at the factory, is the IP address for the fixed, for the wired LAN, not for the wireless. So if you're connecting your Prusa 3D printer with a Cat5 cable or a Cat6 cable, that is the correct address, the one that they print on the test proof. But it's not the one for the Wi-Fi. The one for the Wi-Fi, you're gonna have to go get it out of your DHCP server. It's not gonna appear in any of the documents that comes from the printer, from the factory with the printer. Again, should I have bought the MK4? Hell yeah! I want to buy the MMU3, and I'm super excited. Month of November, I'll get the MMU3. If I have a few views and a few likes on these videos, if somebody watches them, maybe I'll do a video on the MMU3. The print quality is perfect. It's much faster than the MK3. It's not very expensive, and so I'm really happy to have purchased the MK4. Should you buy a MK3 now that the MK3 is $600, or should you save a tiny bit of money and buy yourself a MK4? If you're going to print a lot, I would say go with the MK4. If it's gonna be something that gathers dust somewhere in your garage or your basement, go buy the MK3. If you're a kid, or if you're buying for a kid, buy the MK4, because the MK4 is much easier to use than the MK3, because the automatic first layer calibration. You can swap the steel sheets. It's much easier. The kid is gonna get much better results. You do not want to disgust a kid by giving that kid a lot of work in order to get his prints out. He's going to have to learn CAD software, he's going to have to learn PLA versus PETG, he's going to have to learn temperatures, he's going to have to learn how to use isopropyl alcohol to clean the print bed in a responsible manner. 3D printing is a great thing to learn. However, it should not be frustrating. So especially for a kid, buy a MK4. Should you buy a MK4 as a kit, or should you buy a MK4 assembled? Absolutely as a kit, for all the reasons I developed at the beginning of the first video. Now, last point, why buy Prusa? There's a Chinese brand that sells discounted printers that use kind of the same parts, or similar parts as the Prusas, for a fraction of the price, and they are using the open source firmware of Prusa without publishing the modification that they are doing, contrary to open source licenses. When you're buying Prusa, you're actually subsidizing writing that source code. We need somebody to write source code. We need somebody to innovate. So you're actually subsidizing innovation. You're subsidizing innovation in the heart of Europe. All the Prusa people are really good people. They're on a noble quest, which is to put a printer on every kitchen counter on the entire planet Earth. It's gonna save billions of dollars in terms of cost of getting parts in 20, 30 years from now, and Prusa is part of that movement. It's also going to save a lot in terms of environment, because if you don't have to have a part come halfway across the world in a container or by plane, even worse, and you can actually just, you know, push a button and print a part, you're actually doing a tiny itsy bitsy part at making the world better. And the other final point is when you buy a Prusa printer, you're part of the Prusa community, you get access to the forums, you get a discount on buying your filament. It's not a huge discount, but it's there and it counts if you print a lot like me. And you're going to be able to use the Prusa printer repository called printables.com. It's very important. Join printables.com. Do their competitions. I have been trying to do that. I don't always have the time, but when I have the time, when they do weekly competitions, and you actually can win stuff. You win filament. You win, when you are actually competing, it's on a particular subject. So 1 week it's gonna be doing things for the kitchen, the next week is gonna be for the bathroom, the next week is gonna be for photography, and so all kind of small objects. At some point you're gonna have an idea. You're gonna be missing something at home, and you have two choices. You can buy something that's not quite exactly what you want on Etsy, Amazon, or AliExpress, or you can actually make it yourself using your CAD software. And as soon as you have a 3D printer, you make it yourself using the CAD software. And when you have a competition you're interested in, you can join, you can compete. Your parts are going to be tried by other people, you're going to get feedback. Generally people are really nice. I've put parts that were not tip-top up, you know, up to professional standards, because by training I do finance for a living, and my training is in mathematics and economics, public finance. So I'm very far away when I do engineering from my training. But people are nice. They tell you, okay, it doesn't quite work. It didn't work for me. I printed it. The two parts that you had, part 1 and part 2, weren't fitting together because I had retraction. Okay, how do you figure that out? What was the diameter of, you know, this hole? What was the diameter of that stem? So it's actually interesting. People help you progress. I made a ton of progress on printables.com. It's the best community out there. They allow people to upgrade their models. People can modify your models if you give them the files, and they can do what's called a remix. They can take them and modify them, improve on them. You can improve on other people's parts, and when you do, Prusa subsidizes you by giving you a few meters of filament. When you have a lot of meters of filament, 350 to be precise, which is an entire spool, they send you a spool. So it's a very good idea, especially for education. So I'm thinking that the reason you're buying this printer is for education purposes, I'm assuming. If you're a professional, you're not watching this video. You already know how to assemble a MK4, MK3, and Creality, and you can make a $200 Chinese printer that's missing parts perform like a $10,000 printer. So you're not here to listen to me. So I'm assuming that you're actually looking for a printer for Christmas. Should you buy a MK4? For little Johnny, so he can learn how to do 3D printing and designing parts in his CAD software that he learned in school, like Tinkercad or Fusion 360. The answer is probably yes. I thank you very much for listening and for watching this video, and I'll see you in the next one, and the next one will be about enclosures. I'm definitely going to do one about enclosures because I do not like the enclosure that comes with the Prusa printer. My need is a tiny bit different, and I'll explain why, and I'll offer my solution. Again, thank you very much for watching, and I'll see you in the next one.